Hey everyone, so in this video we're going to be talking about if you should believe a statistical study. So most statistical research is carried out with integrity and care, but statistical research is sufficiently complex that bias can arise in many different ways. So we're going to give you 8 different guidelines that can help you answer the question, should I believe a statistical study? Alright, so first guideline. First thing you want to do is get a big picture view of the study. Alright, so get the big picture, get the overall sense of what the study is. So to help with that, answer the following questions. What's the goal of the study? What was the population under study? Was that population clearly and appropriately defined? What type of study was used? Was that type of study appropriate for this kind of study? Right? So for example, imagine the following news report. So researchers gave 100 participants their astrological horoscopes and asked whether the horoscopes appeared to be accurate. 85% of the participants answered yes, that the horoscopes were accurate. The researchers then concluded that horoscopes are valid most of the time. Alright, so first off, what kind of study was this? Right? So this study was observational. Alright, because they just observed what happened when 100 people got their horoscope. Now, for a study like this, it could have actually been a controlled experiment. Right? So, for example, a couple of ways this study could have been improved is if it was a controlled experiment. Some people could get real horoscopes and some could get fake. Alright, so you have a control group where some people are getting just a fake horoscope. You see how they react, and then you can compare it to the people who are actually getting a real horoscope. Do they act any different from the people who just got a fake one? Alright. Also, in this experiment, we could have made it double blind. So if you remember, a double blind experiment just means that both the researchers and the people getting experiment on, the participants, neither of them know who's getting a real horoscope, who's getting a fake horoscope. Because if the researchers know who has a real one, then their questions could actually lead the participant to lean one way or another. So to keep everything completely fair, it could have been double blind. These are just a couple easy things to see that could have made this experiment a lot better, a lot more reliable. All right? So, guideline 2. Consider the source. So, statistical studies are supposed to be subjective, but the people who carry them out and fund them may be biased. All right? So, for example, if you're looking at a poll, does this, drug work to help ease the pain of something? If you're looking at that poll on the drug's website, well, then it's probably going to be a bit biased because everybody who's on that website is probably for it, right? Same thing with any topic. If you're going to the website that is for a topic, any poll or anything like that on that website is probably going to tend to favor that topic. All right, number 3, look for bias in the sample. So selection bias occurs whenever researchers select their sample in a way that tends to make it unrepresentative of the population. So imagine that you're taking a poll about women's rights, but the entire population that you pick are men. That would be selection bias, because if everybody's men, that doesn't actually cover the entire population, right? Second one is participation bias. So this occurs primarily with surveys and polls. It arises whenever people choose whether to participate. Because people who feel strongly about an issue are more likely to participate, their opinions may not represent the larger population. So a really good example about this is whenever you were picking this class, did you go look at Rate My Professor? Well, whenever you look at something like Rate My Professor, think about it. People are more likely to go and rate their professor if they were either really, really good or really, really bad, right? So if they had a really strong opinion towards that professor, they're probably going to go rate them, which is why there's a lot of 5s and 1s on Rate My Professor. You don't quite see as many like 3s, for example, because it tends to be the people at the extreme who will actually participate in the first place. All right, so another example. Based solely on the information given, do you have reason to question the results of the following hypothetical studies? So a state Republican Party polls 1,600 of its members to determine whether its candidate for the U.S. Senate is likely to win against the Democratic candidate. So the big thing here is it says of its members. So if you poll 1,600 Republicans asking them if they think a Republican is going to win, what do you think they're going to say? They're probably going to be biased towards Republicans, right? So this is selection bias. Because they're only polling people who are going to give them the result that they want. If you actually wanted to make it fair, then you would want to poll Republicans, Democrats, Independents. You would want to get everybody involved. That way you can actually get a fair poll and see what everybody thinks, what the entire state actually thinks. All right, guideline 4 is to look for problems in defining or measuring the variables of interest. So a variable is any item or quantity that can carry or take on different values. For example, a show being watched or the number of viewers in the case of the Nielsen ratings that we talked about in the last one. So those would be variables because they can vary from study to study, person to person, things like that. The variables of interest in a statistical study are the items or quantities that the study seeks to measure. So this guideline just means make sure that the study is measuring the correct things. Make sure that they're not measuring things that don't really have to do with the study or have to do with one side more than the other. All right, guideline 5, beware of confounding variables. So variables that are not intended to be a part of the study can sometimes make it difficult to interpret the results properly. Such variables are often called confounding variables. because they confound or confuse a study results. It's basically just adding in extra information just to make the study look more beefed up and make it harder to read and intentionally confuse you a bit just so you can't read it as nicely or as easily. All right, guideline 6. Consider the setting and wording in surveys. So even when a survey is conducted with proper sampling and with clearly defined terms and questions, it is important to watch out for problems in the setting or wording that might produce inaccurate or dishonest responses. So for example, if a survey asked you, do you cheat on your taxes? Well, just by the wording alone, you're not going to want to say that you cheated on your taxes. So no matter what, you're just going to put no. The wording of it makes you more likely to put no because you don't want to admit to something like that, even if you did. So that would be an example of bad wording. Also, I'm just going to go off to the side real quick. Another thing to watch out for is the first answer in polls are more likely to be chosen. So it's kind of like whenever people always tell you always guess C in multiple choice tests. If you've ever heard that before, this is kind of something similar. In polls, just the first answer is automatically a little bit more likely to be chosen. So how do you get around something like that? Well, you could flip around the answers. So if you're giving 100 surveys, then in half the surveys, you can flip around the answer choices. That way, the first one keeps moving around. So flip the answers. Right? It could be something just as simple as putting the yes response on top, no on bottom, or no response on top, yes on bottom. Flip it around in half. That completely takes care of this problem right here. All right, number 7, check that the results are presented fairly. So the study may be misrepresented in graphs or concluding statements. So later on in the course, we're going to be talking a lot about different types of graphs and ways to present data. And none of the graphs are necessarily better than the others. They're all good for certain things. Certain graphs are better for representing certain types of data. And just by using a different type of graph, or even just shifting your variables around on your graph, you can make your point of view look a lot better than if you had picked a different type of graph. So be wary of that. Also, researchers may misinterpret the results or jump to conclusions not supported by the results. So for this one, keep in mind, we're all human. Researchers can make mistakes too. They can read the results and get the completely wrong conclusion up from it and just run with it. Or they have a general idea after the first few results, so they jump to that conclusion and just keep it in their mind the whole time and don't really follow the rest of the study to be able to sway their own decision. So for example, based solely on the information given about the following hypothetical studies, decide whether you would believe the stated claim. So a new diet program claims that 200 randomly selected participants lost an average of 24.3 pounds in 6 weeks, and that the program works for anyone with enough discipline. So the problem with this is this average of 24.3 pounds. It's the average part, right? Because if it's an average of that, that doesn't actually give you a good enough view of how much weight all the participants lost. So a few people could have lost a lot of weight and others very little. So just to kind of simplify this and get the point across, instead of 200 randomly selected participants, let's say there were just 2, right? One person lost 50 pounds. One person lost 0 pounds. Well, the researchers don't want to show that their diet program only worked half the time and that somebody didn't lose any weight. So they say, oh, on average, they lost 25 pounds. That makes it seem like everybody loses 25 pounds. There's nobody who's going to lose just 0 pounds. So this just isn't enough information for you to really know enough about this diet. You need a lot more information. All right, last guideline, guideline 8. Stand back and consider the conclusions. So ask yourself the following questions. Did the study achieve its goals? Do the conclusions make sense? Can you rule out alternative explanations for the results? And that one's a really big one, in my opinion, because that one's a really common mistake is people see results, they say it's because of one thing, when in reality, a lot of things could explain those results. If the conclusions do make sense, do they actually have any practical significance? So even if a study gets results, it doesn't mean it's actually useful, in other words. So for example, based solely on the information given about the following hypothetical studies, decide whether you would believe the stated claim. The university athletic department sends out a press release claiming that the basketball team has a 64% chance of making it to the NCAA tournament. So, first thing, the 64%. Where does this come from? They give us this number, but they don't give us anything to back it up. They're just pulling this number out of thin air with nothing to actually back up that claim. All right. Also, you have to keep in mind, it's the university's athletic department that sent out this press release. So, of course, they're going to be a bit biased towards their own team. Why wouldn't they be? Of course they want their own team to go, so of course they think they're going to do amazing. All right? So this just isn't really believable. There's not enough information. It's from a source that is definitely going to be biased because we all want our own teams to win. So just keep this stuff in mind when you are looking at studies. Not all studies are created equal. Some are made extremely fairly and in really good conditions to where there is very, very little bias even possible. But other studies, especially things like online polls, can tend to be extremely biased and from questionable sources and things like that. So there's just 8 rules to kind of just think about whenever you're looking at one of these studies. And that will be it for this video.